Good evening, everybody. Welcome to day 3 of Intro to Coding Live. Today we are going to cover Python ordered data structures. Up until now, day 1, we covered the data types and methods. Yesterday, we covered conditional statements, truthy, Boolean expressions, and that sort of thing. Does anybody have any questions on any of that stuff? Any of the exercises or whatnot before we lead into this?
Yeah, just a quick question. When something asks you if it wants to, if something is asking you to make your function truthy or falsy, is that literally just make asking you to set its Boolean as true or false? That's
So it's
just
got to it's got to return true or false. That's what
so
we're
that's just what
talking.
truthy and falsy means.
Yes.
Okay.
And that's it's easy to me. It's easy to boil that down to being a Boolean, some sort of Boolean expression where there's a function that returns true or false, etc. Remember the difference when we were looking at the find method with the string, and that returns a -1 if the word isn't found, or the index number of the first letter of the word that you're looking for. That is not a truthy or falsy thing. Does that help?
Yes. Yes, it does.
Okay. Any other questions? All right. So now we're going to get into today's lecture or today's class. Ordered data structures. You can kind of start taking what you understand about a string and build off on that. So we know that with a string, you can index the letters, and those are in an order, your 0, 1, 2, 3, etc. So what we have are lists and tuples, which are similar in that you can access the indexes of a list, and a tuple is usually an immutable pair, where a list is a mutable uh, collection or a list. I'll dive deeper into that as we go through. Um, but does everybody remember what mutability means?
It can change.
Yes, you can actually change it. So you remember, like when we tried to change a letter inside a string, it's immutable, so you can't. But an element inside of a list, that is mutable, so we can change it. And we'll go through um how to do that today. Just as a quick note, if you haven't gotten your code spaces started, go right ahead. You may not already have the kernel listed, so you should have the select kernel up above. I'm going to expand this a little bit. You just click your select kernel. Remember, it's the user local bin Python we're looking at. So it should be 3.14.2. And then the code, once that's set, you'll see the Python 3.14.2 up in the upper right, and we'll be able to execute the code blocks. Any questions with that? And from here, we're going to kind of expect you to try to have code spaces running before we actually start class, because um, it just helps us move along and get into the content quicker. So just like I was talking about with the strings, we had the indexes. We can access it with 0 through 5, with Python being our string that we're talking about. We have our backward indexing. So we're going to expand a bit on that with the list. So in this first code block here, this is how we create a list. This is one of the ways we can create an empty list. So I have the variable my list, and I'm assigning it to this list with parentheses. Now, if you notice that this is in a different color. If you highlight over it, you see that it's a class. The list word is a reserved keyword because it refers to this data type. So you can't create a variable type with this exact same name. You're going to confuse the interpreter. If we run this, you'll just get these these two little empty square brackets, because that's what an empty list looks like when you print it out. It says that this says we have a list and there's nothing in it. And this is just like I was talking about. The name list is a reserved keyword. So here is how we define a list with members. Was everybody able to see my screen?
No, all I'm seeing is DJ Man has started screen sharing, but I'm not seeing anything.
All right, one second.
Oh, so was
I
it
think
All right, I apologize for that. So as a quick recap, we're on the Python ordered data structures lesson. It's lesson 3 over here. We talked about, I talked about the lists and tuples. So for display purposes, we remember talking about the string with the indexing, the reverse indexing. And just like we were talking about, it's a string is immutable, but a list is mutable. So I'm going to rerun this. And when you print an empty list, you get this set of empty square brackets. Everybody's able to see that, correct?
yep.
Okay. So for declaration inside this inside this darker black box on my screen, we use the list with parentheses, and that's one method that we can use to declare an empty list. Now we remember from day one declaring variables, etc. As we move into where I was just getting to is this piece right here with the list equals the two square brackets and the set of numbers, each separated by a comma. That's very important. This is how we declare a list with information in it. Now, if we run the play button, now we see that this has the list of numbers with the square brackets and everything here. And if I go print type list, you shouldn't really name it list. That should be my list. This is a bad practice to try to use a keyword that I don't. So pretty much when you're using, if the keyword or the variable or what you feel is you want your variable name to be is showing up in orange, then that's kind of an indicator to stop, look at what's going on. Well, orange on my screen, you may be displaying different in your particular editor. So I just added my list in here just to make this a little bit, to make it more clear. And just like we were talking about between day 1 and day 2, clarity is one of the most important things about writing code. You need to understand what's going on, and it needs to be, you need to try to make it so that you can remember what you were doing when you come back a couple days later. And that also generally means it's easier for someone else to read. Now, I added the type in here so that you could see that just like when I highlight over this list keyword, it says the class list up top here. When I print the type, it says the same thing here. So that's what that really means there.
It just telling you what it is then, I guess.
Yes, that's the data type. Okay.
Okay.
So if I went through, and because we know element number 0 translates to the number 1 in this list, if I run this now, do you see how that is an int now?
Hmm.
Because the elements inside that particular element inside the list is an integer, because that's what we put in there as the 1, 2, 3, 4, 5. But when I get rid of the index, I'm talking about the entire list, so my type is a list. Any questions there?
No, that's straightforward.
All right. Now, this is just going through and showing us a couple different ways to create lists. Um, yeah, pretty much straightforward, just like it looks like right here. Um, this first list is a list of integers, or a list of, yes, a list of integers, and it pretty much displays almost exactly like we declared it. You'll see these extra spaces, that's just for output purposes to help make it readable when you're checking this stuff. And you see here that we've made a list of strings, and you still have to follow all the rules of strings. Your string is surrounded by quotes with text with characters in the middle. If you went and did this, if I take the quote out, now it's got a little squiggly because now it's not looking for the string love, it's looking for a variable love that isn't declared. Any questions there?
No,
If
it'll
you
give you an error message now, right?
Yes, that will give you an error message. That's the nice thing. That's the handy thing about those little yellow squigglies is it's kind of like when you're typing in Microsoft Word or Google Docs or I mean, I think even Facebook and some of the other social media platforms has it. Maybe even your mobile messenger, when it starts squiggling under things trying to tell you something's misspelled, kind of the same idea. There's a problem here. Let's stop and look at what's going on. Um, it's handy when you're using code editors and IDEs and that sort of thing, but it kind of helps to try to get into the practice for looking for those things. It's even for experienced engineers, it can become an issue here and there. And there we go. Trust me, it's one of the easy things to miss, even if you're experienced. So, one moment, I'm going to have to pause. Okay, so these first two examples, we've created just simple lists or a one-dimensional list. And now what we can do, what we're doing here is we're creating a list inside a list. Does everybody see how we've got the first set of brackets? We have the elements A, B, C, and then we have the second list in here. And that's shown by having another set of brackets. My code editor is highlighting these brackets in green, and it's a nice handy thing to help you see that this is a different list. And what's inside that list is the D, E, F. So I'm going to I want can somebody take a guess of how many elements are inside the outside list?
I'm going to guess and say 12.
Any other guesses? Well, thanks.
18, 18.
18?
Or
Can you guys explain to me where you're getting those numbers from?
I'm just
I'm
counting
just
everything
curious.
that's in the list. I
Oh,
got
are you counting? Okay, A. Okay.
I'm counting three because of the quotes, and then A, that's
Oh,
three.
okay, okay. So the quote is a string. That tells us that that is a string. Okay.
Mm-hmm.
So that is one element. That's where it could be. It could be misleading, but
I, I'm thinking the same thing as I don't know who posted it, but four because it's A, B, C, and then the list itself is one element. I would say making it four elements within that outer portion, maybe.
yes. Okay. And I apologize, Todd, that it does kind of look confusing when you first look at it. But if we look up here where our Python is, it's still surrounded in quotes.
1, 2,
So
3.
this is 3 elements inside this one. And the giveaway is we look at where our commas are. Okay.
Okay. I'm sorry. I was just guessing. I was just
No
counting
worries. No.
everything. Yeah.
Hey, I'm giving you props because you were the first person that spoke up. So thank you. And I apologize, Janae. I didn't have my chat open. So thank you for the answer for 4. And yes, 4 is correct. We have our first element here, our first, second element, third element. And even though this is a list, it's one element. It's the last element in our list.
That makes better sense.
It can get confusing because, well, the brackets are small. So that's why the editor tries to highlight those in a different color to kind of bring attention to it. Because you could mistakenly think that there are 6 elements in here, or I'm honest, Todd, that's the first time I've heard 12, but
I was guessing because I was
no, it's
I'm
great.
looking for the difficult answer, but it's very simple. It's 4. It's very simple.
Well,
Yes,
and I
yeah.
was looking at the numbers, the 1 through 9, but I was also counting the commas.
Oh, were you? Okay. So
Yeah.
you were looking at the num list. Okay.
Yes.
So okay, yeah. So I should have been more specific at which list I'm talking about too.
Yes. Sorry.
No worries. So the num list that has 10 elements in it. Everybody see that?
Yep, because you got 0.
That's the easy way to count it. If it's all consecutive and then you add your 0, there's your 10. Now there is a function that we'll cover today that'll make that a lot easier. You just call the function and you're good to go. So yes, this second piece is just one element. So we'd have to dive into that to get to the other pieces of that. And we'll cover that later in today's lesson. Which leads us into list operations and methods. Just like with strings, there are methods or functions that you can do with them to get different information out. So we have this list here, the travel bucket list. And now the reason why I put these print statements in is because I can put this in by itself and it will declare the variable. And please make sure if you're following along, please make sure that you play or execute this cell because we're going to use this travel bucket list later. So we need to have it in memory. But the reasoning why I put the print in here is if I comment this out and I execute, generally it will still give output. But this also helps us see that we've actually made the list and it's got what we expect into it. This kind of goes into that print debugging that we were talking about. So we've covered accessing individual elements with strings. We're going to kind of iterate over that pretty quickly because it works pretty much the same way inside lists. But the added thing is we can actually reassign these elements because it's mutable. And we can get a sublist, which is a similar idea of when we were splicing the string where we had the start, stop, and step, and we were getting a smaller string from the original. Now we're trying to do the same thing, but get the elements of the list. So I'll run this, and we've already kind of looked at it. We're accessing the 4th element, so 0, 1, 2, 3, 4. So we're looking at index 4, which is the 5th element in the list, which is Fiji. And that's how we find our individual elements of our list. When we're looking for a range, this right here is slicing, and if we remember correctly from strings, this right here was reverse indexing. So this takes our list and prints it out backwards. Any questions so far? I know I covered
No.
a little bit here. Okay. Now this is the thing, this is one of the things we could not do with the list, where with the string that we can do with the list. So we're taking index number 4 and assigning it to Texas. So we go 0, 1, 2, 3, 4, and now we've replaced Fiji with Texas. And this time we didn't get an error, and the rest of the elements remain the same. Everybody see that? Any questions there?
So when you do that, bottom line is it'll replace. It won't move, but it'll replace. You're telling it to replace Fiji with Texas.
Yeah, it's kind of like, what is it, a swap in place or something like that.
Okay,
You're
that makes
changing,
sense.
yeah, you're changing out what that particular element is. Any other questions? All right, we have some operations, and this is what I was talking about. Instead of manually counting, we have a function called len. Len is short for length. So what we're doing when we add this len, we have to have in our parentheses, everybody remember this is called an argument. So our argument, we're taking travel bucket list, we're specifying that as our argument. We're sending that argument to the length function, and now we're printing it. And our total amount of elements is 7. Any questions there?
No.
All right. Now, everybody remember we covered using in and not in. I believe it was day 1. It was our membership stuff, correct?
Like the hashtag NT.
Excuse me? Sorry, I might have missed that.
So you said the hashtag. I'm not the hashtag. The slant in.
No,
Letter N.
no. That's an escape character. Sorry. No. The in operator. It's a membership operator, so it's in, the word in. So what that does, if we remember when we covered that, we were looking for, I believe we had a list of names or a big long string of names, and we were looking for a particular name inside of it. Similar to how the find operation works. So what we're looking for here is by using the in operator, the first line here, we're looking to see if Fiji is in our travel bucket list. Well, if you remember, we replaced it in this code block up here. We switched it to Texas. So in, this becomes a Boolean statement or a truthy falsy statement. Fiji is not in travel bucket list, so we have false. We replaced Fiji with Texas, so the second line is Texas in travel bucket list, and that is true. You can kind of look at this is the same way we would use inside a conditional or an if statement. Any questions there?
No, it seems very literal to me. You're just asking, is Fiji in travel bucket list? That's it.
Exactly. Yeah, you can read it just like that. It's one of the handy things about Python is you've got a lot of these little keywords and operators that help kind of read it closer to plain English. But just like we were talking about with the and ors, it's not exactly like English, right? So just like with strings, we have other methods that we can do. We have the append method, which we can add another element to the end of the list. There is an extend element, which this says that it requires an iterable for an argument. And what an iterable is something that has indexes. So you could put a string in here because you can iterate over the different string characters, just like we were looking at with 0, 1, 2, 3. We can put another list in here, so we could extend our current list by adding another list to it. Or there are other data structures that we'll cover later that you could add in here. We have the insert method. Now this one requires 2 arguments, where we have I in here. The lowercase I with these 2 arguments is the index of where we want to put the item. So when we're talking about using the brackets with the number, that is an index. So the index always starts at 0. So if I wanted to insert something at the first place using this insert, I would put 0 for my I and whatever I wanted to add in as my X. Any questions there?
Nope, straightforward.
Now, the next one we have is clear. That one's pretty self-explanatory. It just empties out the list. There is a method called index X or index, and the X is this returns the index of the first item of what we put in as X. So if you remember the find method that we used with Python, it told us the index number of the first place it found whatever string we were looking for. So what we would put in here is the element inside the list we're looking for. So instead of putting an index number, we're going to put, like, if we were looking for Fiji, we'd put Fiji in here. And that would give us the index of where Fiji was located. Any questions there? I've got some examples further down that I'll be able to show so you can demonstrate. Go ahead. I'm sorry I cut you off.
No, I was just going to specifically for like index, if we were looking for Fiji, we'd write bucket list dot index and then put up brackets and say Fiji, and it would look for where Fiji is and then give us a number.
Yep, that's right. Count is similar, just like you'd put the element you're looking for, you put that in, that's where your X is in this argument, and it'll count how many times it finds that value inside there. Sort is a method that it sorts the list. So if it'll sort usually alphanumeric. So, A through Z, 0 through 1, etc. Reverse, it sorts it in reverse order. No, I apologize. It takes whatever order you have the list in and just reverses everything. So it doesn't sort it. It just changes, like if you have 3 elements, 0, 1, and 2, it takes 2 and puts it in the 0 spot. The 1 element stays the same, and the 0 element moves to the 2 spot. I can demonstrate that if you'd like to see that.
Go ahead.
All right. So let's open up our practice PY, and we are going to go my list equals 1, 2, 3. Now I'm going to print it. And I'm going to reverse the list and print reverse list. All right, so now when we run this, remember we're looking down here at the bottom. And I'll bring that up a little bit. How about we go Okay. I'm definitely calling something wrong here. All right, I'll get back to you guys on that one. It's not operating the way I expected it to. All right. Naturally, what it should be doing is it should be reversing the elements. So it should do something similar to print my list. It should be doing something like that. All right. I'll look into what I'm trying to access wrong there. And then let's see here. No. All right. I will get that back to you guys on that one. I apologize. But it should be doing something similar to the reverse slice. All right. And we have the dot copy, which creates a copy of the list. So here we have an example of how to use the append. We're taking their travel bucket list. We have the Texas in here, and we're appending Germany. And Germany is this last element in the list. Now, when we were talking about extend, we're adding another list to this. So when I run this, it doesn't insert a list. It extends our current list, travel bucket list, by appending each one of these values after. So we still have one list. Any questions there?
No.
And we were talking about the insert. So like the example I was talking about using the index number 0 or the first place, we want to add Canada in here. So now we have Canada, we have Texas, we have our Germany, we have all of the things that we've done previously. Any questions there?
No.
All right. Now what we're looking at here. Okay. So while append and extend look like they're very similar, they do have some different functionality. With append, we supply it a list, and if we supply append a list, if you notice right here, it added that list as the last element. Everybody see that?
Yes.
So that's different from how we did it before. But this next one is even more confusing. If we look at, we took extend and we added this string. Do you guys see what happened here?
It broke it up.
Do you know why it would do that? Do you have a guess, or it's
Because
completely
it's looking at each element separately as opposed to one word, I guess.
Yes, because remember, a string is a collection of characters and we can iterate through a string. So each one of those characters has an index position. So it added the string index 0, 1, 2, 3, and 4, which breaks out into individual letters. Because when you are calling the extend method, it's expecting a list, and technically it's expecting an iterable, sorry, not specifically a list, but it can iterate through a string and it will give you every character. I promise you, I have made this mistake myself. So it is something that when you see this, this is how you know what happened.
So the way to not allow that to happen, would you use append anyway? Just use
If
append?
if all you wanted to do was add Japan, then yes, you use append. Because extend is looking for it's looking for a collection. It's something it can iterate through. By giving it one string, it knows that it can iterate through each index, which is exactly what it did here. So, and if you were looking to just add this list to the back end of the list instead of add that as one element, this belongs down in extend. This list belongs down in extend, and Japan belongs up in append. Is that clear for everybody? Any questions there? Sorry. We've basically, it's easy to reverse the intent. But this is what happens. This is what it looks like if we reverse the intent. Like it kind of looks like as we go along through our list and all of a sudden we have a list buried inside it. It looks like, well, maybe we just used the wrong method here. And the same thing goes for the Japan. And I do have to say, I have personally done this Japan thing more than once. Okay. Any questions so far?
No.
Nope.
Okay, we have two more methods here, and these have to do with pulling elements out. So we have remove, and what it'll do is it looks for X. X is our argument. In the case that, like, if we wanted to remove okay, so here's the example of what we're trying to do. So when we use the remove, we're going through and we want to get rid of the individual letters here. So we use remove and we have to do the J. I'm going to hit play on this and you'll see, I'll explain this last piece here in a minute. But we need to go through, get each element and remove it so that we can start cleaning up this list. Now, with the way this is working here, just because we specified just one A, so it's only going to get rid of one of the A's. Okay, and that's why we still have this A here. This goes through and we call remove again because there are two A's in Japan, and now we've cleaned out the individual letters for Japan. Any questions there?
No.
So like if we wanted to get rid of Thailand, you want to put the entire word Thailand in here to be able to remove that whole element. If you put something in to remove and it's not in the list, I believe it'll give you an error. So we can test that out by trying to remove a Z. And there we go. We have an error right here.
I got a question.
Go ahead.
If you say, for example, remove T from my tribal bucket list, it'll remove, a capital T, the T in Texas and the T in Thailand, or
no, because it's going to be the whole element. It's not going to take that out of
okay.
any of those elements. So it has to specifically match that element. Okay?
Okay. All right. Got it.
I'm going to comment this out because we've already removed the A. Otherwise, it would give me an error because I had already removed it. Everybody saw the error when you tried to remove something that's not in there?
Yep.
Okay. Any questions so far?
Can you do the same thing to remove indexes? The remove?
Removing indexes, you use... Okay, so that's where pop comes in. Okay. And that's
Oh,
the
okay. I see that. I see
that's
that. Okay.
actually the next example that we're moving into.
Okay.
Now, pop has got something additional that it does because it returns it. So you can actually pop the item out and use it somewhere. So what we're doing here, if you see, we have this first variable, spouse bucket item. This is a new variable we're declaring, and we're assigning it to the travel bucket list, calling the pop method, and -1, if we remember correctly, that is the last element in the list. So what we expect is that should be this list right here. When I execute that, we're printing the spouse bucket item first, which is Peru and Dominican Republic. And if you notice, now we print the travel bucket list. It is taking it out of the list. It's handy because generally when you want to pop something out, you want to use it for something. Any questions there? Remember, remove is looking for the specific element and pop is looking for an index. Remove, I believe remove doesn't return anything. Let's have a look. Come on. We'll run that. This is a built-in way to get some. There we go. This is a built-in way that you can get a little bit of a description on what a function does. And no, remove doesn't return anything. So when we remove something, we're just doing that. We're tossing in the trash. We don't care about it. So generally, if you want to retain it, you're going to use the pop method. There is a way to use the remove method by using an index. A lot of times, if you just don't assign, if if I just called this travel bucket list pop, I'm going to do an example here. I've got my list equals 1, 2, 3. And now if I just go my list dot pop -1, notice I'm not assigning it to anything. Print my list. This is how we can get rid of it. And if we don't need it as a variable, we just discard it that way. Everybody see the two usages of how you can use pop? Any questions there?
No. It does the same thing as remove. It takes it away and because you didn't assign it anywhere.
Yes, this particular use does the same thing as remove. If I assign it to something, then I plan on using it somewhere. So you've got a little bit of flexibility on what you want to do. Okay, let's clear this. And now we can search for the index of an element. And the example we've got right here is looking for the index of the element of the string Texas. So when we run that, that's going to give us the index for wherever the Texas element is. So you could easily use that if you didn't know the element of the item you wanted to pop when you're trying to actually pop it out of the list and use it for something. You can kind of combine stuff, and I'll show you a little bit of that in a little bit. I'll show you how that works in a little bit. I apologize. And then we have, I believe we may have already talked about count. If we supply the string, so we're talking about the actual element value that we're looking for into count, it'll tell us how many times it shows up. So we have Texas in here once, and there we are. I know we took a short break earlier. I could give you guys, do you guys want another 5-minute break and then we'll pick up on the hour? Do you want a 10-minute break and then run till another 40 or 50 minutes? What do you guys feel like doing tonight?
Take a 5 minute, I guess.
Yeah,
All
about
right.
5 minutes.
All right, welcome back. We just covered in the method index and the method count. As we remember, these are list methods. So the next one we have here is sort. And sort has another argument that we can set, and it's specifically the reverse argument. Now, basically, this is a toggle of which direction we want to sort it. So we've got, by having reverse set to true, we have taken and sorted the list in reverse alphabetic order. But if I take and I set this to false, now we have it in our alphabetic order with Antarctica, Argentina, etc. Pretty quick and easy.
Is that the default for that?
Yes, if you
Okay.
take out reverse, it defaults to your normal order. And this is alphanumeric, so if you have numbers in there, it'll do all of its sorting and that sort
Oh,
of
there it
thing.
is. Sorry, I didn't see that part. Yep, right there in front of me.
And then we add the reverse in here, set it to true. And just like we had with the previous example.
Why are you putting true and false? Is that necessary every time?
If you want, okay, so the reverse in there, true, is only necessary if you want to reverse the sort. So if you want to sort it backwards. This example, it's alphabetic. So we've got Thailand, Texas, New Zealand, Morocco, Italy, Ireland, etc. But if I went through and I sort my list here, my list dot sort with reverse. Usually this is easier to see when you see it with numbers. And then I print my list. And down on the bottom, we'll see that now we have the 3, 2, 1. And if you start adding in words like Alpha, Bravo, and Charlie. When I sort that, we get an error. Okay. So if we switch out our numbers, so apparently it will, oh, yep, it won't sort both numbers and letters. Do you see how we reversed the sort to Alpha, Bravo, and Charlie? Now we have Charlie, Bravo, Alpha. And that's what we're doing with the reverse is true right here with the countries, states, and whatnot. Does that help clarify it?
Yes.
Okay. A lot of times it's easier, especially with sorting, you can kind of see it with numbers. I thought this was going to work with both, but I was wrong about that. Now, sort changes it on, if we look at how we're calling sort right here, We didn't assign it to a different variable. We just called sort, and it it changes the list that you have, and now its actual state is the result of that sort. Does that make sense? I'm trying to make sure I explain that correctly. So we don't need to assign this to a variable. When we call the sort method, it changes travel bucket list. But the method sorted doesn't change it. And that's why we've got this example here. When we use sorted, we assign it to another variable or we lose the result. And that's why we've got two variables here. We have other sorted bucket list, which is taking these are the same. So let me change this equals false. We'll try that to be able to demonstrate the differences. There we go. The reason why they looked the same is because the reverse flag was set to the same thing. So it wasn't actually changing anything. But now that I've set the reverse to false, now we're in alphanumeric or A, B, C, etc. list order, but we haven't actually changed anything to the original list. So that's why we have two print statements here. The first print statement is our original list, which we have sorted with reverse equals true in the previous example, and that has stayed the same. But we changed reverse to false, which in this case, you'll get the same result if you just take the reverse completely out. And then we have that back with the normal sorted order. Any questions there?
Yeah, I have a question.
Go ahead.
So, I actually got a type error that just does not make sense to me. It says type error, and then it has like in the quotation the less than not supported between instances of list and string.
So it sounds like are you doing that inside a sort?
Yeah, I'm in the sort. Yeah, the one that you have the let
Okay,
me check.
so what I'm gonna have you do,
Uh-huh.
which of these two blocks are you in? Are you in
Actually, I ran the both of them and got the same error
you
message.
got the same error message. So that means we have something different that happened. I think I know. I think if we go back up here, did you run this one? Did you run this block right here that has the pop -1?
Yes, I did. And let me see. It doesn't actually look the same, like the results does not look the same.
Okay, so what's different in your result?
So I have Japan and then Japan
You
on one line, and then there is a list underneath
you
that.
have all of the characters for the Japan,
All right, let me see here.
like each one of the individual letters. Let's see here.
You're right. No, it looks the same. JAPN.
So we should have run that, and then you should just have 1A and the list here. Let me get this arrow out of here. And then we needed to run. Oh, the reason why that happened is because that's already. Let me.
Yeah, because I just ran it again. I know I'm getting an error. Before I didn't have an error for that one with Japan. And
With
now I
this
have an error.
because does it say X not in list?
Yes.
Okay, so that means that's out of there. That's actually good in this case. So that means you've already run that part.
Okay.
This pop, if you run it again, it's going to remove Australia. Okay.
Okay, so I'll run it again.
So the first value should be Australia and you should have the rest. Does it look like that?
No, it has Argentina on one line and then a list
Oh,
underneath.
the reason why is because we sorted it. Okay. But it did just take one element out.
Okay.
When you're looking at that second line, do you see any lists inside of there or no?
Yes, Peru, Dominican Republic.
Okay. So what happened is we missed this pop segment.
Uh-huh.
That's why that list is still in there.
Okay.
And when we continued. So what we can do is just before the sort, actually, here, do this one right here. Do you see where the call for the index Texas is?
Okay, let's see. Yes.
Okay. So what I want you to do is replace Texas with that list. That list should be, make sure you put the brackets too. You need the brackets, and you're looking for Peru and Dominican Republic.
Okay, let me see. Syntax is in.
If I run it, it's going to give me an error.
Okay. I guess I was looking at the wrong Texas. Let me find
No
it.
worries.
Um,
We're looking for the
yes.
one that's calling out index. It should be under, there's a little table that's titled syntax and description, and inside it talks about index and count.
Okay, just is just okay, syntax list variable index. Is that what is it under the list operations and methods or is it further up? Because
It's after that pop one, right where we were when
okay, so
you
it's
when you
further
did the
down.
pop. Yeah, it's right after that.
Okay. Okay, index X, okay, with the Texas, okay. So I'm
So
there now.
replace the Texas with that whole list that you were looking for. Okay? Because we still have that sub list in there.
So the whole list will, I'm confused right now. So the whole
So
list is the one from before?
the Peru Dominican Republic part, that's the only part
Oh,
we
that's
want.
the only part.
Yep.
Okay.
But you want to make sure you put the brackets in and the commas. You can go into your other output and just copy it. You could paste it right in there and it should work. Because once you run that, that should give you a number.
All right.
Excuse me, real quick. It'll give you an error because you're putting in 2 without the brackets, right?
It'll give us an error because we removed this list, but that list is not missing from her list. So it's going to
Okay.
give her the index. And then what we can use that, we can take that index number, put it in pop, and fix her sort.
Okay.
This is how the debugging went. When she said that the Peru Dominican Republic was in there, that tells me that the list is still in there. We need to be able to remove the list. However, we already sorted it, so it shifted where the index was. Everybody see what I'm talking about there?
Yeah. Okay.
Okay. So I just have to, okay, I see what
Now you should be able to execute it, and it should give you a number.
okay, I'm looking at so it's going to be in the parenthesis and
Can you read mine?
yeah, I think I can see it. Well, I just want to
Let
make
me
sure I have
try
the right
to.
number. So at the end has 2. Okay. That one.
2 parentheses. Yes.
Okay. So I get 12 now.
Okay, so now that you have 12,
Uh-huh.
this is what I'm going to want you to do. You can actually just go right underneath it
Uh-huh.
and type the travel bucket list dot pop, open parentheses, and put 12 in there, and then run it again.
Okay. Travel bucket.
Yep, travel bucket list. That's the whole name.
List. Dot pop and 12. Okay, and run it again.
Yep. No errors?
Yeah, I got one because I didn't write pop, I write poop.
Oh, okay.
Okay, let's see. Yes. No, it just has Peru, Dominican Republic.
You executed the box and we did not get any errors, right?
That's right, no errors.
Okay. Now, in front of that travel bucket list, I want you to put a pound sign so it grays itself out. We're commenting it out, okay?
Okay.
Now hit execute again. And you should get the same problem that I have. You should get an error that says X not in list, correct?
No, it actually turned the 12 to 14.
All right. We'll pick yours back up because I'm gonna dive deeper into that, okay?
Okay.
Because we're about to move into tuples, so that's not going to actually affect your travel bucket list,
Okay.
but we can review through yours and see what happened, and I can we can dive into this, okay?
All right, thanks.
Yeah, not a problem. So the next variable type we have is called a tuple, and this is called an ordered collection. They're similar to lists, but they're immutable. And we use parentheses instead of brackets, okay? Now, as we remember, immutable objects, we can't add, subtract, or edit any of the items. If we want to change something, we have to create a new tuple. Any questions there?
No?
On this right here, this is how we declare them. Very similar to how we did the lists. Go ahead and run that. And we've got our 3-element tuple. And then our 1-element tuple here. Just like with the other data structures we were talking about, tuples have operations. We can use a lot of the same operations as we use with lists, except for the ones that actually modify the tuple or modify the list, because it's immutable, so we can't utilize that. So we have our coordinates tuple here. We're assigning the length variable to len, which was the length that we used with the list. And as a side note, you can actually use len with a string to find out how many characters are in the string too. We're printing the length, so we have two elements inside our tuple. And then here we are using the in membership operator to see if 5 is in the coordinates tuple that we established up here. We've assigned that to the variable is 5%, and then we're outputting that as false. Any questions here? These ones are pretty straightforward, kind of review of what we've already done. So now, here's some other methods. These 3 methods also work with lists, min, max, and sum, or these functions. So what we're doing here is we have our tuple with several elements into it, ranging from 1 to 678. So the first function we're calling is min, which gets us the minimum value of our particular collection, or our tuple in this case, which we have 1. So our first value is 1. We get the maximum, So our maximum is 678. And then we have the sum operation, which takes every single element and adds it together, provided it can be added together. So if you mix data types, we'll get an error in this. If we put a string in there, we saw that on day one when we tried to add an integer and a string. We would get that same error here if we had mixed types. Any questions here?
No.
Nope.
Okay. And just for note, you can use this min, max, and sum on your lists as well. It'll do the same thing between those two types of collections.
Oh, okay. Real quick, dumb question here. In order to distinguish between the tuple and the list, how would you do that? Would it be the brackets or the parentheses? Is that how it's done, or is it something different?
Yes, visually, the way we're looking at this, we can tell it's a tuple because it has the parentheses. If I change these to brackets, actually, I'll demonstrate that right now. So we're going to print the type of my tuple. We'll run this again, and we see our class is tuple. If I go through and I change this to brackets, and I run it again, you see how
Say
we're a
list.
list now? Yes.
Got it. All right. Told you what it is. Got it. All right. Good. Thank you.
Yep. And when you print them out, they'll also show that with your output. It'll put the brackets if you've got a list. It'll put the parentheses if you've got a tuple. All right. Now, sort changes the order of the list. We do know that. But if we run it here, we get a none here because these sort doesn't work with a tuple because you can't change the order of it. Oh, you know what I needed to do? I needed to run this again. And now I should get the error. There we go. What I did was I reassigned the tuple as a list. So when I started trying to do my tuple sort, I did not get an error the first time because I changed it to a list. So I had to rerun it as the tuple so I could get this error. And this is just a reminder that you cannot sort a tuple because you cannot modify the order of what it is. If
That's
you
why it gave you an error, right?
not,
Sorry.
that's why it gave me an error. No, thank you very much. Any questions with that? Okay, so there are some other things we can do. We can concatenate, just like we were doing with strings. We can concatenate two tuples to create another tuple. And we can duplicate a tuple using the asterisk or the times operator. Okay, so when we run this, we have our tuple 3 is this top one where we took 1, 2, 3, and we concatenate with 4, and we get 1, 2, 3, 4. With this bottom one, we're taking 1, 2, 3, which is 1, 2, 3 right here, and we're multiplying it. We're duplicating it element 0 times, which should turn out to 1. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, I'm sorry. Element 0 of tuple 2, which is 4. So we're duplicating tuple 1 4 times. I apologize. I wasn't really reading into that the way I should have. And the biggest thing I needed to pay attention to was the fact that we're looking at tuple 2. Element 0 is 4. So what this really says is duplicate tuple 1 times 4. Everybody see where I went a little? That may have been a little confusing at first.
Yeah, now I see it. Tuple 2 is in both places, and it's telling you what to do.
And there's 4 copies. Come on, get out of there. Oh my gosh. Well, I'm trying to underline the last one, but I'm getting a pop-up here.
It's four sets of 1, 2, 3.
Yes, that's the key right here. So this right here could have just been written as 4, but I read it incorrectly because I was looking at the 1 up here because that was the first element here, but this is tuple 2, so that our first element is 4. So yes, we're multiplying by 4. Any questions? I know I drew that one out a little bit.
Yeah, I have a quick question. Explain to me why the zero bracket is after tuple 2.
So the zero bracket, tuples, just like lists and strings, have elements. So the 0 refers to the first element.
Uh-huh.
So it's in tuple 2 is the only element. So yes, it doesn't really make a lot of sense because you could have just typed the number 4 there. I do get that. And that's why I was getting a little bit tripped up trying to explain it. But what this is you can access members of a tuple the same way you can access numbers of a list or a string by using the index. That's what this is demonstrating here.
But like you said, you could just wrote 4 times 4 then it would have done the same thing.
Yes.
All right.
However, if I didn't know what this number was and I knew I just wanted it to be multiplied by whatever that number was, that's where this starts becoming more useful.
And it's the first one, so it's 0. Okay.
Yes, it's the first
It's the
element,
only
so
one.
it's 0. Does
It's the
that
only
help?
one.
Yeah, that's where it wants you to start from the first element, which is
Yes.
1.
The first element is, well,
Well, yeah,
oops,
the
I've got
0,
it
which is
pointing.
1. Yeah.
Well, I've got it pointing at the wrong one. So where I was explaining it was confusing because I had talked about tuple 1, but the variable is actually tuple 2.
Oh, okay.
That's where I got confused I kind of mixed up my explanation there. So the first element of tuple 2, or the only element, is 4, and that's why we've got 4 copies of the
Okay.
first. Yeah.
That makes more sense because I changed it to 1 to see what would happen, and I got an error message saying it was out of range. So
Yes, because element number 1 does not
does
exist in
not
tuple 2.
exist. Yeah. Okay.
Now that you have the 1 in the index, how about you can change where this says tuple 2, change
Uh-huh.
that to tuple 1 and then run it and tell me what you get. Oh, you could do it with the
Okay.
0 or the 1.
Okay. So I get the 1, 2, 3.
And then
And
1, 2, 3,
yes,
right? Okay.
Yep. Because it's referring to that placeholder, that number, or that element.
on the top. Okay.
So if I change this to element number 1 and run it, and we have 2 copies because in tuple 1, the second element is 2. I do realize that the way I was first explaining it to it, I was talking about the element that was in tuple 1 when I should have been talking about the element that was in tuple 2. This is the error that you were talking about because the index is out of range.
Right.
Because tuple 2 does not have a second element. So when I change that back to the 0, now I get the 4. Does that help clarify things? This is how you can maneuver your way through both tuples and lists the same way.
Okay. I got it. Thank you.
Okay, not a problem. So we've gone through lists and tuples. We understand that lists are mutable, so we can use operations like extend, append, pop, remove, and tuples are not mutable. If we want a different tuple, we have to create a new tuple or reassign it just like we do with strings. These are both really good data structures to understand. I personally have used lists almost more times than strings, to be honest, because of the mutability and just the flexibility of using when you're using lists. And it's usually when you're dealing with a lot of types of data. You need them. You need to be in a collection. And these will become more of the reason why they're like this will become more evident when we get into loops on day 5. Uh, does anybody have any questions? Want any clarification over anything we talked about today?
I'm good.
Okay. Just like we had with lesson 1 and lesson 2, there's a few assignments at the end here. You could go through them, get some more practice. And the exercises folder also has a few exercises. I still prefer using the practice.py. You can easily just copy and paste this stuff over here. Just remember that instead of looking for your output underneath the box, you're going to be looking for it down here. Now, if this gets really cluttered up for you, you can always type out the word clear, CLEAR, and it'll clear it all out for you. So you got a nice little clean slate. You can move this up and down depending on how much viewing area you got, and you can, or how much viewing area you want, and you can scroll it up and down. Again, I highly encourage you use the practice.py and get used to writing Python in that style, because Jupyter Notebooks is a great learning tool, but that's not what you're going to be really using if you're building software outside of this particular outside of this particular environment. So it's really handy to get used to that, and yeah, it's just good practices. Thank you everybody for attending tonight. I'll be in the room for a little while if you've got any questions regarding any of the exercises from day 1 and day 2. And we will see you Monday when we cover Python unordered data structures. All right. Thank you very much, and see you Monday.
Thank you.
Thank you. See you
Thank
then.
you.